this is the Raspberry Pi. It controls the whole project. It has the flash server running on it, and it listens for inputs from the sensor modules. I have it hooked up to the relay board, which is the red and blue board that you see there. That is hooked up to a 12-volt power source to do switching, but you could just as easily hook it up to 110 and control household appliances. This here is the actual Raspberry Pi itself, and that antenna you see is the NRF24L01 module. Here I have two scripts and one HTML file that run on the Raspberry Pi. The first script controls the listening for messages from my Arduino base sensor nodes. And it also controls the automation of the Raspberry Pi's GPIO pin. This block of code controls the NRF24L01 modules that do the communication. Here we have a dictionary with our sensors, and then a dictionary with the GPIO pins and what relay they control. This block of code controls all the automation. For fan state. Fan state reads GPIO pin 16. And then if not fan state, so if fan state's not true, which in this case would be a low input, then it'll check if sensors 1, node 1, the temp sensor on that is greater than or equal to 80, that pin will go high. And then after it runs, if fan state is true, which is a high input, it'll check and see if that same sensor is less than or equal to 79.9. This is in a while loop, so this keeps running over and over and over again. Down here we have the code that actually controls the reading of the buffer from the NRF24L01. We initialize the receive buffer, we start listening. Here, if we've been listening for 3 seconds, we break out of this little while loop, and then we read the buffer. We'll print it out, what's actual on the buffer, which is a bunch of just bits. Then we're going to convert those bits to actual readable characters. Down here is all data handling and processing, which splits up that string we received that has all the sensor data and then adds it into our sensors dictionary. Then we dump that all into a JSON file, which gets sent over to our Flask. Flask is a web server that you can execute Python scripts on. That also is going to control the GPIO pins, but from human input. The app roots are the actual pages they visit. So when somebody visits our main page, it's going to open the sense file, and then it's going to send all the GPIO pins to outputs, and then it's going to send our sensors and our outputs into template data, which gets sent to the HTML file. Down here is our action, which is when somebody clicks on a link. If they click on, it'll send that corresponding GPIO pin high. If they click off, it'll go low. And then it'll update the value in the GPIO input dictionary. This is our HTML file, which basically controls the web interface that you've seen earlier. It uses something called Jinja templating, which allows variables and for loops to be run off of. Template data is stored in dictionaries. Down here is a little script that we won't change our page, so it stays on the main HTML page when somebody clicks the on or off, but the on or off will still run. And we are going to refresh this page every 5 seconds so our sensor data always updates. So here's my daughter operating the web interface. Every time she clicks a link on the web page, a color will turn on. Now here comes red. So here is my web interface. The web interface is running on the Flask web server. Up here is the sensors. One is the first sensor node, and it's saying it has a light sensor, and that value of that pin is 1.19 volts, which means that it's rather dark where the light sensor is. And it's got a temp sensor, and it's 78.54 degrees in that room. Oh, there went the motion sensor. 1 means that the motion sensor is returning a high value, which somebody walked by the motion sensor. And if you noticed, the relay turned on, and now that it just went on again. So it means somebody's walking by my sensor node. This updates every 5 seconds to keep a current value. Or if you click one of these links, which correspond to one of the relays that it is controlling. Over here, you're wondering what this is. This is just the raw data the Raspberry Pi is reading. This is the communication script in action. So this is the bytes that it is receiving, and it's translating the message. All zeros just means that it didn't receive anything. If we find right here is where it received the message, and the message translated to that. These are my Arduino sensor nodes. They consist of the NRF24L01 module, an Arduino Nano, and this one has a light sensor and a temperature sensor. That right there is the NRF24L01 module. And they're small, but you can barely see the light sensitive resistor. Here is the motion sensor, again consisting of an Arduino Nano, and that right there is the motion sensor. If somebody were to walk by it, it would trip the relay that is connected to the Raspberry Pi. That is the Arduino Nano. I have 2 Arduino scripts here that run each on one of the Arduino sensor nodes. In the setup, it basically initiates the radio, which is the NRF24L01 module. And we got a couple of strings that are used so the Raspberry Pi can decipher what we are sending it. This one controls the temp and the light sensor. So when it gets the temp, it runs this little function I've written, which runs the input on the temperature pin, which is A2, then stores it to temp, which it'll eventually send it in this string right here is where we make the node, then we separate her, which is a semicolon, and then A, which is the phrase temp, then we separate that again, and then we put the actual temp value. And then the Raspberry Pi is going to read this, split it all up, and throw all this data into dictionaries. Here we actually write that, which sends it out to the airwaves to be received by the Raspberry Pi. In this case, and then we're going to delay for 30 seconds so we don't overrun it. This is for the other Arduino sensor node that controls the motion sensor. Again, we got the radio stuff right up here. A couple strings to help decipher. And then, in this case, it's a little more involved. We only want to know when our motion sensor changes. So, if it goes high, which means somebody's walked by the motion sensor, we're going to let the Raspberry Pi know that. Then we're going to enter a while loop that will constantly read the motion sensor and look for a low. And once that goes low, we're going to send that back to the Raspberry Pi and let it know. And then we're going to break out of this while loop that we're in, and then we're going to run the code all over again, and it's going to stay here and look to see, well, it's not going to stay there. It'll see if it's high. If not, it'll just keep going. It'll just keep going.